You've probably already done it today, right? Pulled out your phone, typed in a destination, and just like that, you get the best route, your exact arrival time. You can even see what the building looks like before you get there. It feels so simple. I mean, it's basically magic. But behind that little blue dot on your screen is one of the most complex software systems ever built. Seriously. So, how in the world does it actually work? I mean, think about it. How does a map in your pocket know about a traffic jam 100 miles away, or the new opening hours for some tiny cafe in a country you've never even been to? Well, let's get into it, because the answer is pretty wild. It involves satellites, some seriously smart AI, and just a mind-boggling amount of data. And just to give you a sense of the scale we're dealing with here, get this. Google's AI has analyzed over 220 billion Street View images, yeah, billion with a B, and that's not just so you can, digitally walk around a neighborhood. No, that's the raw material for building a smart, self-updating map of the entire planet. So, where do you even start? Well, before a map can tell you where to go, it has to, exist. The very first step, and honestly, it's a monumental one, is to create what's called a digital twin of the physical world. Basically, a perfect digital copy of every road, every building, every landmark out there. Okay, so how do you build this massive digital twin? It all comes down to two different views of the world. First, you've got the view from above. We're talking satellite and aerial pictures, more than 80 petabytes of data from Google Earth Engine. That's an insane amount of storage, by the way. This gives you the huge big picture layout. But that's not enough. You also need the view from the ground. And that's where Street View comes in, providing that super high-res ground truth that fills in all the little details that matter.
And getting that ground-level view, this is where it gets really fun. It's not just about strapping a camera on a car. Oh no, to map the entire world, you have to get creative. They use tricycles to get through parks and down narrow streets, snowmobiles to map out ski slopes. They've got people hiking through places like the Grand Canyon with these camera backpacks on, and my personal favorite, they've literally mounted the whole system on a camel to map the desert. A camel.
Okay, so you have millions and millions of photos. What happens next? Well, they all get fed into a process called photogrammetry. It sounds super technical, but the idea is actually pretty simple. Powerful algorithms take all those individual, overlapping pictures and just digitally stitch them all together. The result? Those totally seamless 360-degree views that make you feel like you're standing right there on the street. So now we've got this gigantic photo album of the entire world, which is cool, but pictures by themselves don't really make a map, right? This is where the next crucial layer comes in, the AI cartographer. Think of it as the brain of the whole operation. Its job is to take all that raw visual data and turn it into structured, intelligent information that you can actually use. And the absolute cornerstone of this whole thing is a process called geocoding. Honestly, it's like the map's universal translator. It takes an address that you and I understand, like, 1600 Amphitheater Parkway, and it converts it into the super precise latitude and longitude coordinates that a computer needs to drop a pin on the map. And of course, it works the other way around, turning those numbers back into an address we can read. It's fundamental. And this is that AI brain in action. You're looking at a data pipeline that is always working 24/7. The AI is constantly pulling in new info. For example, it'll use text recognition on a Street View photo to read a street sign and verify the name. It'll crawl a restaurant's website to see if its hours have changed. And, maybe most importantly, it analyzes all of our anonymous GPS signals to figure out what traffic looks like in real time. It's just this continuous cycle. Input, process, output, over and over again. Let's take a real-world example, like keeping the info for 200 million businesses up to date. Here's how it works. First, an algorithm might flag a business because its hours seem outdated. Then, the system kicks into gear. Step 1. It scans the official website. Step 2. It literally looks at the sign on the storefront in the latest Street View pictures. And get this, in some cases it will even use an AI to call the business and ask what their hours are. It's this incredible multi-step verification process, and it's happening millions of times every single day. Okay, so we've got our super accurate, super smart map. What's next? Well, now we get to the really good part, the navigation. This is where the ultimate routing engine comes into play. It's the computational powerhouse that can find the absolute best path from point A to point Z in like less than a second. So how does it do that so fast? Well, the foundation is a classic algorithm called Dijkstra's. Now, Dijkstra's is super thorough. It will check every single possible path to find the shortest one. guaranteed. But on the scale of the entire planet, that would be incredibly slow. So Google uses a much smarter upgrade called A-star search. A-star has what you might call GPS intuition. It uses clever estimates, or heuristics, to basically say, hey, the destination is over there, so let's focus on paths heading in that direction. It's a way to intelligently ignore all the bad options and find the best route almost instantly.
But here's the key thing to understand. Best route doesn't just mean the shortest distance. Not at all. It means the fastest time. And to figure that out, the engine is juggling a crazy number of variables. It's looking at live traffic from millions of us on the road right now. It's looking at 20 years of historical traffic patterns. It's even predicting what traffic will be like later in your trip. Plus, it factors in stuff like road restrictions, weight limits, and even how statistically difficult it is to make a certain turn at a busy intersection. It's wild.
So where does all that amazing real-time traffic data come from? Well, the biggest source is us. It's the anonymous speed data from millions of Android phones out there that creates this incredible live picture of how traffic is flowing. That's then combined with other sources like official data from government road sensors. And of course, there are direct reports from other users, when they flag an accident or road construction ahead.
All right, so when you put all of these pieces together, the data collection, the AI brain, the routing engine, you start to realize something. You're dealing with a map that literally never sleeps. The biggest challenge isn't just building the map one time. It's the constant, never-ending job of keeping it perfectly in sync with the physical world that changes every single second.
Yeah, this is not some static image that you just download. It is a living, breathing system. And get your head around this number. Over 100 million updates are made to the map every single day. A new coffee shop opens, a road closes down, a speed limit changes. All of that has to be reflected on the map like right now.
And that really gets to the heart of the whole thing. There's a great quote that puts it perfectly. The physical world is in constant flux. Maintaining accurate data on places is an immensely difficult engineering problem. And that's no exaggeration. It's one of the biggest, most complex challenges in modern engineering, period.
So what we've really unpacked here is this incredible system of layers, all working together perfectly. First, you create that digital twin of the entire planet, using images from the sky and from the ground. Then you have this AI that acts like a tireless, autonomous mapmaker, turning all those pictures into a smart map. And finally, there's that powerful predictive engine that looks at the past, present, and even the future of traffic to find you the fastest way to get where you're going. It's all of that, working together, that makes our world navigable.
In the end, the map is a reflection of our world, right? It shows our roads, our businesses, how we all move around. But it's also a reflection of you, of each of us, through our saved locations and search histories. So here's a final thought to leave you with. The map reflects the world, sure, but what does your map reflect about you? Something to think about next time you fire it up.